Simple compounds have two combining partners. Each partner has a valence, which means combining power. Here in water, the hydrogen has a combining power of 1. But oxygen has a combining power of 2. So the oxygen bonds with 2 hydrogen atoms. The periodic table can help us to guess element valencies. For radicals, the charge is the valence. Please use our 4-step method to work out the following compound formulae. The steps are valence, cancel, cross, and radicals. In 1788, one of the convict tasks was to gather seashells and roast them in ovens called lime kilns. Quicklime or calcium oxide formed first, then slaked lime or calcium hydroxide when water was added. This chemical was used as a crude mortar in sandstone walls. The two parts of this chemical are calcium ions from group 2 and the hydroxide radical with a charge of 1-. Step 1. Write the formula with the valencies at the top. Step 2. Cancel. There is no number that we can divide by. Step 3. Cross the numbers over. Step 4. Radicals. We bracket this radical because it has a 2 brought down. If it was a 1, we would leave out the brackets around the radical. We now rub out the working. It has 1 calcium, 2 oxygens and 2 hydrogens. The mineral cassiterite is mined in Tasmania. It is an oxide of the group 4 metal tin, whose name in Roman times was stannum. Much of our food is stored in tin cans, where a thin layer of tin coats the steel, which would normally rust. We start by writing the 2 elements with their valencies at the top. In step 2, we cancel by dividing both numbers by 2. In step 3, we cross the numbers over. There is no step 4 because there are no radicals in this formula. So we simply rub out the working, which means the 1s. In the huge Pilbara region of West Australia, we have created some of the world's most efficient iron ore mines. Central to these deposits are banded iron formations that date between 2,400 and 1,800 million years ago. The rocks have light and dark bands. The dark bands are rich iron ore, and the reddish bands consist of cherts with iron oxide staining. The black iron ore is hematite, which is iron 3 oxide and sometimes called ferric oxide. Ferrum was a Latin name for the transition metal iron. Iron can have a number of valencies. Here it is 3, where it has the colour of rust. Step 1. We write the symbols with valencies. Step 2. We cannot cancel. Step 3. We cross the numbers over. This is the final answer, as there are no radicals or ones to rub out. The grey zinc sulphide mineral, sphalerite, is found together with lead and silver minerals in a number of locations, including Broken Hill and Queensland. It is the source of the zinc that we use to coat iron to prevent its corrosion. Zinc is a transition metal with valence 2. In sphalerite, it is bonded with the group 6 nonmetal sulphur. The rule for finding its valence is to subtract 8 from all elements after column 5 in the periodic table. So sulphur's valence is 6 minus 8, which gives minus 2. Step 1. Write the two elements and their valencies. Step 2. We cancel by dividing by 2. Step 3. Cross the numbers over. And step 4. There are no radicals, so we rub out the ones to give us the formula for zinc sulphide. Alkaline chemicals have a soapy feel because they react with fats and oils in the skin to make soap. Our pioneer ancestors used sodium carbonate to help them wash clothes. They called it washing soda or carb soda. It does not pollute the environment or harm human skin like some modern chemicals do. The two partner chemicals are sodium from group 1 in the periodic table and the carbonate radical that carries a charge of 2-. Step 1. Write the formulae with valencies at the top. Step 2. We cannot cancel. Step 3. Cross the numbers over. Step 4. Radicals. This radical is not bracketed when a 1 is brought down. So we rub out the 1 as working. Since before biblical times, Middle Eastern cultures were attracted by the pretty blue and green copper chemicals, azurite and malachite. They used them as cheap gemstones, in paints and as sources of copper. The chemicals are complex mixtures of copper carbonate and copper hydroxide. We will write both formulae. In each case, the transition metal copper has a valence of 2. First, copper carbonate. Step 1. Formulae with valencies at the top. Step 2. Cancel. We divide by 2. Step 3. Cross the numbers over. Step 4. The radical is not bracketed as a 1 is brought down. So we rub out the 1s as working. Second, copper hydroxide. Step 1. Write the formulae with the valencies at the top. Step 2. We cannot cancel. Step 3. We cross the numbers over. In step 4, the radical is bracketed because a 2 is brought down. Then we rub out the 1 as working. Human bones are complex structures that make our red blood cells and allow us to move and stand upright. The hard parts are made of calcium salts that are related to this white chemical called calcium phosphate. For continuing healthy bones, we need a diet with adequate calcium and the sunlight-generated vitamin D. Load-bearing exercise and weight control also help. If you fail, your bones will break in old age and you will become stooped. Calcium phosphate contains the group 2 metal calcium plus the phosphate radical with valence 3. Step 1. Write the two formulae with valencies. Step 2. We cannot cancel. Step 3. Cross the numbers over. Step 4. The radical is bracketed as we brought a 2 down. The chemical has 3 calciums, 2 phosphorus atoms and 8 oxygen atoms. This is magnesium bicarbonate. Some people drink this and believe it does them good. Who knows if they're right? Magnesium bicarbonate contains the group 2 metal magnesium and the valence 1 bicarbonate ion. Step 1. Write the two formulae with valencies. Step 2. We cannot cancel. Step 3. Cross the numbers over. And step 4. The radical is bracketed because a 2 is brought down. To conclude, we rub out the 1 as working.